piecewise function. We're going to go, in fact, we're going to go over all of it. So we'll start with the piecewise function. So go ahead and fold it up. Today's date is the 19th. Yeah, you're going to put your, and then you got your worksheet from class, the trig worksheet, the angle worksheet. Just put that at the back at the end. So we're going to do it. Yeah, we're going to do the piecewise function together. And then get out your laptops with graphing calculator. I'm going to show you how to put a piecewise function in graphing calculator. So, yeah, so put it all together. Fold the trig worksheet, like make it the last page. Make the trig the last page or in the front, I don't care. Fold it all together. The date is the 19th. Okay, so here was that piecewise function, beginning at -7.5 with a constant rate of -2/9 over the first interval, and then over the next interval, constant rate of -5/6, and then over the last interval, 4 to 9 8/7. Okay, so if you understood what we talked about Monday, there's no computations to do. We can set up this whole function. We can just write everything down. There's no calculations, no decimals, no fraction work. You just write everything down. So let's start with, what about the intervals? Maybe let's mark off the intervals. What's the first interval for the first piece of the function? -7 to -3. Is that right? Okay. So this is going to be the first interval. Then what's the next one? -3 to 4. Okay? So let's call it interval number 1. And then you got interval number 2. And then from 4 to 9. Interval number 3. So we've got 3 constant rate of change functions that we're going to take. The first one, we're going to take this piece of it for this interval. And then we're going to take this piece of the second one. And then we're going to take this piece of the third one. And we want to make sure at the breakpoints that they are connected. So that the y value at the right side of the first interval then is the y value, starting y value, the left side of the second interval. So what is the... So in graphing calculator, have that ready. Open a command line. So we want to define this as a function, so we can use our favorite name, which is f, most common. And remember, when we do a function, what am I going to do to actually denote this f as a function? What do I do? Control 9. Okay? And so we'll make it function of x. I kind of misled you a little bit with this x and y stuff. We can use the argument of a function to be x and just define a function. It won't graph that. Okay? It won't graph it until then in the later line you say y equals f of x. Okay? So we'll use x for the argument to set up this function. And so then to break it up into pieces after you hit equals, you hit Control A. Control A. And you're going to hit it, if you do it once, you'll get a two-liner. And then every time you hit Control A again, it'll just give you another line. So we want one more. Control A. To do which one? What now? Doesn't work? So can someone open up on your PC, open up the, what is it? Thank you, Brian. Control Shift A. Thank you. All right, so in the first line, what's the rule for the function in the first interval here? What do we want? What's our general form for linear equation? Slope times change in x. Slope, good. Slope times change in x. So y equals slope times, and what's the change in x? X minus a plus b. Is b the y-intercept? No, not in this form. What is it? It's the y-coordinate when x is, or just in general. B is the y-coordinate when x is a, right? We got our starting point AB. Our starting point AB. Okay, so what's our slope in this first part? -2/9. Then we want parentheses. And then what do we want? X minus -7, right? Plus, okay, what is B in this case? 5, our starting point. So our starting point is -7, 5, and we have the rate of change of -2/9. Okay, and then in the second interval, which is from, oh, sorry. So we need to define, so we go back up to that, put the cursor up there by the first, the first line. We need to say what piece of this are we going to take, okay? So we say if, and then we define that interval, so x is going to be from -7 is less than x, and then we want less than or equal to, because we got to decide which the actual value -3 has to belong to one of the two rules, either the first or the second line. So we'll make it belong to the first rule. We'll go -7 x less or equal to -3. Okay, so on Mac it's option less than. Anyone figure it out on a PC?
Control shift less than.
Control shift less than. Okay, so then our rate of change changes. What does our rate of change become? -5/6 times the change in x, which is x minus -3. Okay, what are we going to add to this? Meaning, what is our starting point of this interval, the y value of our starting point going to be?
F1.
What's that?
F of x is the first equation.
Okay, so which x? Yeah, right. So now we want to invoke. We want to get the ending y value from this. So what is the ending y value from our first interval? Yeah.
F of -3.
He wants f of -3. Is that what it is? Can we use the function within the function? What will this tell graphing calculator to do? Where will graphing calculator go? It's going to go back to the definition of the function x and plug in what? -3. And what line will it invoke? First line, because we said this is -3 is included in this interval. It's going to invoke, and it's going to give us the y value, which will be the ending y value. Does it make sense? It's called a recursive. This is a recursive idea that it's using itself to continue the definition. So then we want that if, what's the interval there? -3 less than x less than or equal to 4. And then the last line, rate of change, 8/7 x minus 4 plus starting y value for the third interval is the same as the ending y value for the previous interval. How do we denote that? F of 4. Yeah, Tom
How
Paul.
do you get a third line within the function?
Control A. Every time you hit Control A, it'll give you another piece of does it work? Or Control Shift A. So we want f of 4. And that's if 4 is less than 9. Uh-oh. If 4 is less than, darn it. I'm going to start over. Okay, x minus 4 plus f of 4 if x is less than, darn it, 4 less than x less than or equal to 9. Okay, so once you have it all looking good there, I already did it earlier here. Like that. So once you have it looking good, then we can, so that won't graph it. So in the past I've said anytime you put x in, it's going to graph. If you define a function with the argument being x, it won't graph it. It'll just define the function. We need to then say y equals that function to graph it. Pick your favorite color. Hit graph, and you should get it. Any questions on either the problem, setting up the piecewise function, or getting graphing calculator to do it? Everyone's successful. Erica.
Why is it less than or equal to?
Less or equal to which one?
Like all of them that have the less than or
Okay, so say we just put less than -3. What would graphing calculator do then if we put if we invoked f of -3? Where would it go? Would it belong in this one? If it was x was less than -3?
No.
No, and if x was greater than -3, would it go in this one? No, so it'd be undefined. We wouldn't have defined what the function is when x is -3. So we want to define it at every value. So we're going to go up to and include -3, but then we're just after -3, we're going to start the next line. If we don't do that, then -3 is not part of the function. Okay. Other questions? Everyone able to do it? Okay. I'm going to erase that for next class. Last chance. Okay, so we're talking about rate of change. We're talking about these piecewise linear functions. Okay, so a piecewise linear function, we have the functions that have a constant rate of change, but over different intervals, a different constant rate of change. So as we go from one interval to the next, the constant rate of change changes to a different constant rate. Okay, how did the graph that we just produced reflect that? How did the graph that we just produced reflect that it had different constant rates of change over different intervals? What's that? Right, so we know that the value of the slope is the rate of change. So visually, we're going to get a different slope when we move on to the next interval. Okay, so we've been working on the equation of a line, and now we just did piecewise equation of a line. Or no. Really? Let's go with that. Okay, so far we've been building and talking about functions like the one on the right. So we can think of this in a different way now. Instead of having our second quantity be on the y-axis, we can actually make the rate of change, right? The rate of change be the y-axis coordinate. And so if we're talking about constant rates of change, then what will those graphs look like? Horizontal lines, constant rate. So no matter where we put our delta x, so if the delta x is over here, for that entire change in x, we're showing the rate is constant at the value 2. And then we can change, if the rate stays constant, then we can change delta x, and the rate you have the same constant rate over every interval of length delta x. Okay? That's also seen in the graphs we've been doing. You have the same relative size of y, changes in y to change in x, no matter what delta x is. Okay? Same constant rate of change over every interval of length delta x. So this is a kind of a new view for us, looking at a graph of the rate of change. We're going to be dealing with rate of change graphs now for the rest of the semester. So this idea of a rate of change function versus just a function showing the two quantities. Okay, so here's a rate of change function. So this is our, we'll call it rate of change functions, we'll name them R. So this is the rate of change function of the function f. This is the rate of change function for some function f. And it's saying that it has a constant rate of -1 when x is less than 0, and a constant rate of +1 when x is greater than or equal to 0. So when x is less than or 0, constant rate of -1. When x is greater than or equal to 0, constant rate of 1. So can you come up with what the function f is? What is the function f that has this rate of change function? So you take a minute and see what you come up with. What function f has this rate of change function? Go. And sketch it, or yeah, sketch it. Make a sketch. Describe what will happen. What does this mean? What function f has this piecewise constant rate of change function? Think about the piecewise function that we built, right? It had different rates of change. How were those represented? How were those rates of change represented in that piecewise function that we built? So now you're kind of similarly building a piecewise function given these rates of change. All right, I'm going to take a walk around. So think about it. Show me what you got. Nothing so far here. Did you get everything you learned about rate of change? So give me a sketch. Draw it from. This graph is telling you that when x is less than 0, the rate of change is -1. You're telling me that the rate of change is 0. So if you have to ask yourself, what is rate of change? For rate of change to be -1, what does that mean? For rate of change to be -1, what does that mean? I haven't seen the sketch yet. Okay, we got 1. We got 3, we got 4, we got some good ones over here. Okay, so it's a little bit of success. What does a rate of change of -1 mean? There's we got two powerful ways to think about it. Choose whichever one you want. How do you want to think? What's the rate of change of -1 mean? spending a week and a half on what is rate of change. And so I tried to emphasize we need these ideas. Remember, go over the videos over and over until you memorize this. What does a rate of change of -1 mean?
So for every 1x, y increases by 1.
Good. All right. So what it means is for every change of x, the change in y will be how many times as great as that? -1 times as great as that. So for every change in x, we're gonna do what? We're gonna go down that far. That's what -1 means. For every change of x, no matter how big it is, we're gonna do the same decrease in y. So what will that look like in a graph? Okay, and then similarly, rate of change of 1. For every change in x, the change in y will be the same as it, right? 1 times that change in x. So you get the same changes in y. It's the only rate of change where this happens. Your change in y is the same as the change in x. That's a rate of change in 1. So now, can you make a sketch? Or can you imagine it?
It should be
We'll make another round, see if we can get some 50-50.
every change in x, it's the same. This change in y.
For every change in x,
Okay, yeah. So
change
like,
in y is the same as the change in x. So what will that look like?
so is that
Yeah.
2? So
If you went over 2, how far up would you go? 2. And from there, if you went over 1, how far up would you go? Well, that's the rate of change.
yeah, okay.
And now we want the function. We want the function that has that rate of change.
Is it like absolute value?
Okay, now more people are getting it. Okay. So, screwed up in here. All right. Sterling, I want to hear from you. I like yours. Okay. Most of you got it. This is what it is. Okay. Comments, observations. Sterling, was that the graph you had?
Kind of. Mine was on the negative, positive. They did the same type of data.
He had something different. You had, so what was yours again? Tell me.
Mine was pretty much the same thing, except the line going down was the negative one.
This was like,
the x-axis, not the y.
so yours was like this?
Yeah, it went down to -1, and then the other one was positive 1.
Like this?
Yeah.
All right, what about Sterling's? So Sterling's graph is the red one. What do you guys think about that? Does it fit the criteria? Yeah, so given a rate of change function, is there only one function that has that rate of change function? How many are there? Yeah, all we need is that rate of change. It doesn't tell us about any function values, it just tells us the rate of change. So that could be at any, those could be at any y values as long as that rate of change is -1. Same with the positive one. So there's some different possibilities here. In fact, infinite. How about that? Does it work? How about that? Yeah, these all work. Okay, the one that many of you thought of is fine too. Anybody have a question? Okay, let's talk about, you had some reflection questions on the taxes. Okay, so this is a great way to talk about these rate of change functions and the function for which it's the rate of change. All right, so tax. So say you're single and you make $23,500. How do you use this table to find how much tax you owe? So you're single. Has anybody ever done their own tax? Oh, good. So a handful of you. Okay. If you're single and you don't have a lot of investments and you just have maybe 1 or 2 jobs in the year, it's not a difficult thing to do. So say you made, what did I say, 23.5? Okay, if you make 23.5 and you're single, everyone look and say how much tax do you owe? So how to use this to compute your tax? So if your income is 23.5, what's your tax? So you go, basically you have these different brackets, right? So you're going to look for the one that where it fits. Oh, I didn't. Okay, so how about, I'm going to make up a new example. 26,420. $26,420. Nice little summer job, right? Okay. Very nice summer job. All right, 26,420. You would owe how much tax? Yeah, you just go and you look to find out what interval you're in for your earned income. Or your taxable income, sorry. So after your deductions, your taxable income, and then it just tells you. 35.45. So the question is, where does this table come from? So how are these numbers, where do these numbers come from to determine what your tax owed is on different taxable incomes? Anybody know? Mathematically, so it comes from Washington, first of all. It comes from Washington, D.C. They decide how our tax works. But mathematically, what's happening here? So where does it come from mathematically? Anybody know? Yeah.
It's the K value when you divide whatever you owe by how much you actually is taxable.
Okay. So you said a K value? All right, so there's a rate. Do all people pay the same rate? Does everyone pay 20% of their income, for instance? No. How does it work? Okay, piecewise function intervals. What happens in intervals? So the more that you make, what happens to your rate? The percent that you pay on the more money you make increases. It's called a progressive tax rate. Progressive tax rate. That's what we have in our country. So here's the idea of a progressive tax rate. Okay? So this is a function, right? So the name of the function, like the naming function's f. Now the name of this function is tax rate. The name of the function is tax rate. And so what does x represent in this function? Taxable income. So this function, you're going to plug in taxable income. And what is the output of this function? Tax due. Is it tax due? So if my taxable income is $100,000, I'm in this interval here, and my tax due is 0.28. Was that 28 cents? What is that? Is that the tax due? It's the rate, right? The output of this is the rate. So if you make $100,000, the rate that you pay is 0.28. But do you pay 0.28 on all of that $100,000? No. So here's how it works. So if you think about when you make money over a course of a year, say we're at 100,000. Perfect. So someone makes 100,000 in a year. Okay. How much money have they made at the beginning of the year? 0. So at the beginning of the year, how much tax have they accrued or owe? 0. Okay, and so over the first period of time, they're going to make their first 8,370. Okay, and then from 8,370 they're going to keep working. And we can think about this maybe like this is March or something, or this is, April. And they're going to get up to 34,000. And then after that, getting into fall, they're going to come to a point where their total income that they've made that year is 82,400. So for this first $8,370, how much tax do they pay on that? 10% of every dollar in the first 8,370 is going to be taxed at 10%. Okay? In the next, and then starting with the next penny, the next dollar after 8,370, what percent will they pay on those dollars? 15%. Similarly, 25%. And greater than, when they've made more than 82,400, that's where they start to pay the 28%. Okay, so how do these numbers represent a constant rate of change? So let's look at this one right here. How is that a constant rate of change? It's the rate of change of what with respect to what? How is 0.25 a constant rate of change? Okay, it's going to be a horizontal line, but the number 0.25 is a constant rate of change of what quantity with respect to what other quantity?
Tax owed by taxable income?
Tax owed by taxable income. So it's like, it's the constant rate of change of tax owed with respect to taxable income. You agree with that? So if we think of that as relative size, so for every dollar that you earn greater than 34,000 and less than 82,400, for every dollar that you earn, the amount of tax you owe is how much? How much tax do you owe on each dollar between 34,000 and 82,400? 25% of each dollar. So it's the relative size of, right? Relative size of how much tax you owe compared to how much you make. 25% of it, right? 0.25 of whatever you make is taxable. So it's how fast your tax goes up. How fast your tax goes up. At what rate is the tax going up when you're making these dollars? Is it going up slower or faster for these dollars versus these dollars? Slower, right? It's going up at 0.1 of whatever every dollar that you make. Now it's going up at 0.15 of every dollar that you make. So at these breakpoints, what happens to the rate of change? It changes, it increases, right? So that's what happens at these breakpoints. Anybody have a question? Okay, so what about another function? So this is the rate function. So if we were to graph this, it would look like, if we were to graph taxable income on the x-axis and tax rate on the y-axis, what would the graph look like, just generally? Can you imagine? Yeah, so some of you are saying it. So let's see. Sterling.
What did you make a series of
Yes. Yeah, excellent. Yeah, perfect. And then you recognize that, maybe you recall that from your homework. Okay, that was the image that you had in your homework. Okay, here's a different function. This is the tax function. Okay, this is what's the input and the output of this. So what's the input of the tax function? Or what does x represent? Okay, again, taxable income, but now we got a different output. What's the output of this one? Jessica, you got them backwards. What's this one now? What's this one spit out? Or maybe I misheard you.
It's not the rate.
No, the last one was the rate, right?
The tax due.
This is the tax due. This is the tax due for that taxable income. And we know it's a lot more complicated than just it's 28% of all your income, right? Because of this progressive thing where the rate goes up for different dollars that you earn. Okay, so in what way does the tax system and the point slope formula force us to define it this way? What's our point slope formula? Let's see here. Alexis, what's our point slope formula?
The function of x, the x minus a plus b.
Okay, y equals x minus a plus b? Close. Brian, what's our point slope formula? A over x. Yvonne, what's our point slope formula? Change in y over change in x. Megan, what's our, we're 0 for 4. What's our point slope formula?
Sorry, I was like,
Okay. Jason. M. X minus A plus B. How does the way the taxes are set up force us to use this point slope formula in order to get taxable income?
This is compounding every bracket.
Okay.
As your income increases,
Okay.
it's going to add like the tax from the first bracket, and then it's going to add the tax from the second bracket,
Okay.
and it's going to compound it at each of those varying rates of change.
Okay. All right. So let's break this down. What is in this formula? What is y?
What is tax due?
That's our tax due. On what is our taxable income in this here? X is our taxable income. So tell me what x minus a would be. So for instance, let's compare it down to this here. If x is our total amount of taxable income, say it's $20,000, then what is x minus 8375? This is important. So suppose we're at $20,000, what is this value, x minus 8375?
The taxable income that is taxed at 15%.
He wants the taxable income at 15%. Or, yeah, what were you going to say, Erica?
Isn't it 10%?
At 10%.
It's a taxable income greater than 8,375.
Okay, yeah, so it's at 15, it's not 10% because the money less than 8375 is at 10, this is at 15, right? So both what Trevor and Danny said were right, that it's the amount that we're taxed at 15%, and what is that? That's the amount after the first $88,375 earned. So it's the amount that we've earned in this bracket. And so therefore, we tax it at this rate. So then what is this whole thing? Somebody new. Patrick.
That's the amount of money that's being taxed at 15% and it falls into that bracket.
The amount of money that's being taxed? Is that what you meant to say? I think you're thinking the right thing. It's the amount of... This is the amount of money being taxed in that bracket. So what do we get when we take 15% of that?
The income tax that's owed?
Is it all the tax that's owed?
No, just that's in that bracket.
This is the tax owed in that bracket, do you see? Okay, and then why do we add the tax of 8375? So
Because we've already,
That's going to be the tax that you already paid at 10%.
it's going to be all the tax you paid at 10% for the first $8,375 that you earned. So we're going to take all the money that we earned in the previous bracket, or all the tax that we owed for the previous bracket, and we need to figure out how much money we've earned in the new bracket, and we want 15% of that added to the previous tax that we've accumulated. Okay, so I want you to find, as an exercise, find how much tax you would owe on $50,000 by hand. Okay, so talk through that process. How much? What's the tax on $50,000 according to the progressive tax code? Work together.
You want just a line? Or
I want a value. I want the value. I want to know how much tax, if you made $50,000 over the course of the whole year, how much, sorry, if your taxable income was $50,000 at the end of the year, how much would you have owed in taxes?
You would max out the first bracket, right?
You start at the upper bracket.
Yeah.
No, I have 44,000 minus 8,000.
I think it looks like this, I'm not sure.
So that is the
That'll be one.
tax at 15%.
Plus.
Some of that, right? And then you see this amount, 44,000 minus 8,000.
50,000.
You see that that's the exact same thing, just rearranged. Community property division.
There's a little bit of work to do, huh? It's not one quick calculation. But we want to go through that process and understand that process, how this thing works.
Oh, I did it wrong.
Yeah, that's, what's the exact same? This is that, yeah, that's the exact same. Just the order.
Okay. How'd you have to get it? Is that what it says to do?
Yeah, I mean, it's like.
How do you get the tax?
Okay, plus the 867.
And this is.
Make sure you get it. Anybody have any questions? Understand the process.
So, basically, this part here,
The second bracket, I would do 34,000. For the third
I like
bracket,
34,000 minus 8,375.
and then the third one would be 50,000.
Are we getting 9? Is it? What'd you get for that?
8,680 bucks.
So follow what the function says. So we're going to put 50,000 in here. Where are we going to start? Let's put 50,000 in. We're going to start here? It's actually equals 50,000.
Oh, no, so should we start at 25% like that?
Right, so x is 50,000. If you were to invoke this function, what would invoke first? When x is 50,000? Yeah, you're going to be in here. Okay, so you can start by, so how much of your income is taxed at 25%? 50,000? No, so only in this bracket. So the first 34,000 are taxed at a different rate. So this in parentheses is how much is taxed at this rate? 16,000. 50,000 minus 34. Okay, but that's only the last 16,000 you made. You also have the tax on the first 34,000. How do we evaluate that? How do we evaluate the tax at 34,000? Well, we use the function 34,000. Plug that into x. You see? So we start here with 50,000. So there's 50,000, and so we have 16,000 taxable in this bracket at 25%. So that's the last 16,000 that you made. You paid 25% on that. But now we have to get the total tax due, we have to add the tax that you paid on the first 34,000. And so we take 34,000 and we plug it in. And where does that take us? Takes us to the second line where we're going to put in what? So now we can find, so 34,000 minus 8375 represents your taxable income in the 15% bracket. So this will be the amount of tax that you pay at 15%. But then we need the tax for 8375, so we're going to plug it in again. And it's going to take us here. And then we can get your first 8,375 are taxed at 10%. What do we get for an answer? Just so we can check with each other. $8,681. Anybody have a question? The key here is how this relates to our piecewise linear function. Each one of those is you see that each one of those is an m times x minus a plus b. B is what? It's the amount from before. That's what we said, like the old y value. Plus how much we're going to change y, or how much new tax do we pay at this new rate. Which, sometimes we're going to be right in the middle. But our total is going to be right in the middle of a bracket. So we've got to figure out how much is taxed at that rate. And then that's the amount of tax at the rate. So each one of those, like your homework, is a point slope formula. So I'm going to just show you one thing. Okay, what am I showing here? This is the rates, right? The rates for more and more income earned, you get higher rate in intervals, right? So that's showing the tax rate. So what happens to your tax due when you go from one rate to the next? Yeah, the rate of change increases. So the rate of change, here's our 10%, and then that kink represents the switch to 15%. And then the next one was 25, is that right? Okay, I will post homework for Friday later on today.